All right, guys, in this video, we are going to continue with this 6.4 section on circles and ellipses. And I'm going to continue to reference back to the equations that we had with the ellipses and we put in our little foldable in class. So make sure to keep those handy so that you can reference those as well and see what I'm talking about. But we're just going to jump right into looking at these examples here. If you missed the first video where we talked about what ellipses are and all the different components of them and how to kind of, in the equations that you're going to need, then definitely go back and watch the first video. But in this one, we're just going to go through examples. So, all right, example 2. This is to find the vertices and foci of our ellipse here. Now they have shown it in a format that is a little different than what our equations are referencing, because the equations that we had referenced them as being like fractions. You'd have x squared over a number and y squared over a number. And then it had said that they were equal to 1, right? So I'm going to bring those equations back up here so that we can see what I'm talking about. But in both situations, whether we had this center at 0, 0, or if we had it at the origin, we did not have a number in front of the x and the y. We had the number underneath it, right? And then we had it as equal to 1. So there's a couple methods that you can go. There's a couple methods you can do to kind of get around this. But what I'm going to suggest we do is I'm going to first see what I can do to get this value to be a 1 on the right side. And I think the easiest way to do that is going to be just to divide through by 36. And that will cause us to have a 1 right there. So just rewriting the problem. But like I said, what I'm going to start out with is just dividing through by that 36. And if you divide by 36 here, it would divide by 36 on the other side, but it just treats it like each one of these was individually divided. So that's how I'm going to show it, because I think that that's easier to see. All right, these guys cancel out. It'll just leave a 1 on that side. But on this side, this is going to reduce a little bit. 4 over 36 will reduce to be over 9. So this is really going to be x squared over 9 right there. Then we also have this 9 and the 36 will cancel. 9 goes into 36 4 times. So we'll end up with a y squared over 4. And this is equal to 1. So what I should be able to do is see the formatting here as a ellipse. It has not been shifted, so you don't see the formatting with the center being somewhere weird, right? This is what the format looks like if something has been shifted, but I don't have anything added to x or y, and so, this is going to have a vertex at 0, 0. So we're going to also reference those equations and say, okay, cool, how are we going to use that? Which way is this opening? Are we opening horizontally? Are we opening vertically? Which set of equations should I work with? So what's important is not just seeing is x first or is y first, but I need to see is x over the bigger number or is y over the bigger number? Because if you remember from our equations and what we talked about in our last video is that the a value is actually the bigger value to b. So a is going to be bigger than b in all of these circumstances. So if x squared is over the bigger value, that's like having x squared over a squared. And that means that this is going to have a horizontal axis, okay? So we're going to follow those equations with the horizontal axis. And also keep in mind that I should probably figure out the a value, the b value, the c value even, the one that's talking about the distance from the center to the foci. And so we are going to need to do some solving here. But it's not too bad, because if x squared is over a squared, then that means here that a squared is 9. That means that a is going to be, you could look at plus or minus 3. You could even just account for just a positive 3 because of the way that the equations are set up in our foldable. Okay, let's look at what's the b value then. B is the one that's under y here, right? That's the smaller out of the a and the b. B should have been smaller. So b squared equals 4. And that means that B is going to be, we could look at plus or minus 2, and then go from there. Really what A and B are indicating is they are indicating lengths of segments. That's the whole purpose of them. And so honestly, we would typically just look at that as plus, but it doesn't hurt to remember that you have plus or minus, because a lot of the circumstances you're going to deal with, you're going to need plus or minus for these values in here anyways. Okay, the other thing that I need to know, okay, we had already decided that our center was going to be at 0, 0, right? Center, 0, 0, open, horizontal. Okay, we're just going to abbreviate. All right, so we've already established we got A, we got B. But if I'm supposed to be finding my vertices and foci, I can use the A value to get the vertices. But to get the foci, I'm going to need C. So that's where I'm going to use the relationship that we had in our notes. Looks very similar to Pythagorean theorem, but A squared equals B squared plus C squared, okay? A squared equals B squared plus C squared. So we're going to do that. A squared equals B squared plus C squared. All right, so that means that I'm going to have my A squared value, which had been 9. We've got our B squared value, which had been 4. Subtract that, we get 5 equals C squared. So C is going to be plus or minus the square root of 5. Okay, so that gives me a value. Don't give me a decimal. I don't want that. I want to have exact values. Okay, well, if I have the A, that allows me to get my vertices. If I have the C, then I can get my foci. And that's all this question had asked for. So let's give those two things. For my vertices, okay, since my center is at 0, 0, it's pretty simple to give them. We had decided that this opened horizontally, and we're at 0, 0 for my center. So for my vertices, we've got plus or minus A, 0. And then for my foci, it's plus or minus C, 0. So those are the equations I'm looking for to fill these in. So for vertices, we had plus or minus A, 0. And then for my foci, we're going to have plus or minus C, 0. Done. Those are our answers. Okay. All right. Next one. We'll probably try to speed some things up a little bit now that we've done one problem. Just keep in mind what we're doing is we have to first figure out where's the center. Are we opening horizontally or vertically? So we know what equations we're working with. And then from there, we can start kind of picking things out. Okay, so number 3 says find an equation of an ellipse with foci as at 0 plus or minus 3. They said the minor axis has a length of 4 and sketch a graph. So I'm going to get the equation first, and then we'll sketch a graph of that. Now, when I see that the foci is 0 and then plus or minus 3, and then I look at my equations and I think, okay, which one of these things is that more likely to fit? Okay, well, 0 plus or minus a number, that would put me at my center being 0, 0, and my vertical axis. That doesn't quite match the horizontal one. If you look at these guys over here, they don't show a 0 because this is trying to indicate that your center would be in a different location, right? And so my center being in a different location, I don't think that's the case. I think it's going to be at 0, 0, because that the foci that they have listed, that more cleanly matches here, the 0 plus or minus C. So that actually just gives me the C value by looking at what they've given. I can see it's going to have a center at 0, 0. I know it's going to have a vertical axis, and I see the C value just from seeing those foci. Okay, so I'm going to look at these guys, my foci here. And I know because of the foci being at 0 plus or minus 3, this tells me that C, we're looking at plus and minus 3. Okay, we're also looking at my vertical axis type of situation. So I'm just going to abbreviate this. Vertical axis. And then we're going to say our center at 0, 0 as well. Those are two important things to note just from the fact that the foci is 0 plus or minus 3. I also said that my minor axis has a length of 4. Now I want you to remember what minor axis was. The minor axis has to do with the shorter axis on your ellipse, and that value is equal to 2b. So if our minor axis is 4, that means that 2b is equal to 4, which means b is equal to 2. Okay, so right there, I've got my C, I've got B, and I am supposed to figure out the equation, right? Well, in order to write my equation, we've determined we've got a center 0, 0. We've determined it's got the vertical axis. I need to know my A and my B value. I have B, but I don't have A, which means let's use that equation that A squared equals B squared plus C squared equation to solve and find the A value. And once I know it, I should be able to write my equation and we can get a little sketch. All right, we know, oops, I still want to do Pythagorean theorem exactly the same way, but this one's a little different. So B squared, we're looking at B is 2, 2 squared is 4. And then C squared, if C is 3, 3 squared is 9. So I'm just kind of making some shortcuts here so that we can get through this. A squared equals 13. So A is going to be that square root 13. Okay. Let's get a little equation then. Okay. So a nice little equation. I may just use this section over here to sketch a graph of it. So I'm going to give my equation right here. All right, I know I'm supposed to have y squared over a squared, so I'm just following the equation that we have for this type. That means as y squared over 13, we are separated with a plus x squared over b squared, so b squared was 4, and that's equal to 1. So this right here is an equation to model this ellipse. And then we need to give a little sketch, okay? Well, we know it's going to have a center at 0, 0. Pretend I can draw, guys. The center is going to be at 0, 0. All right, we know that the minor axis, they had said at a length of 4. So if this is going to have a vertical type of shape, that means that the major axis is going to be on my y-axis. And this minor one is going to be on the x-axis. Okay, so our minor axis has a length of 4, so all the way across would be 4 units wide. So we're going to kind of go from here to here. Remember that the major axis, that's the one that we get from the 2A. A itself indicates how far from the center to a vertex. So if I wanted to know that, I should get a little decimal so I can graph that a little easier. It's going to be about 3.61. And so I need to go 1, 2, 3, 4, a little bit more than halfway between those two. 1, 2, 3, 4, a little more than halfway between those two. And you just kind of do your best to make a little oval shape. Look like a little football. It doesn't have to be gorgeous. You know, you could include those foci. That's a nice, important thing that we could include, those foci right in here and right here. But, you know, there's a little sketch of the graph. That's good. All right, example 4. Example 4 says to find standard form of the equation for the ellipse whose major axis, so they're giving me stuff about the major axis this time, is has endpoints at -2, -1, 8, -1, and a minor axis length of 8. All right, so I want you guys to pause this video, see if you can't break it down a little bit yourself before I go over it. Now that we've done a couple of problems, got some of this under your belt, every single problem is going to be different. So I can't just show you an example of everything that there ever is, okay? I want you guys to maybe pause the video, see if you can kind of piece together how this one could work, and then come back when you're ready to look at it together. So if they say, if they say that our major axis has those certain endpoints, there's a couple ways you could go about this. I'm just so kind of used to using distance formula that I like using distance formula to get a length of something. So you could definitely do that. Some of you guys probably would just graph it and kind of count. Or you can tell easily just because they do have the same y value. You could tell the distance between those two pretty easily. I'm just going to show out the algebra for it because for some people this will help. But however you can get the length of your major axis, which we know is 2a, however you can get that, that's fine. I'm going to use distance formula. That's what I'm going to show out. And that would be taking 8 minus a negative 2, which makes plus 2 squared, and then negative 1 minus a negative 1, which makes plus 1, and then square that. 8 plus 2 is 10, squared is 100, and then over here, negative 1 plus 1 is 0, so that's not even important to put. The square root of 100 is going to be 10, so a is 5. Okay, so however you get a, that's fine. For me, I think that, I don't know, I honestly probably would have just counted to see what's the difference between these two. But you do you, okay? But yeah, that gives us the distance between our values there. Okay, so the major axis itself is 10 units long. That makes a half of that. That's 5, okay? So you do have to remember if you counted the length of it to get a, you actually have to cut that in half. Okay, the next thing that I really should find if I'm doing the standard equation is I also am going to need a b value. They had told me that the minor axis had a length of 8. So that's pretty simple. Like our last one, if our minor axis was given to us, you can just say 2b equals that number, which means b would be 4. And then what did they say? They said, what else do we need? Oh, we need to figure out where our center is. Okay, so we don't know that. We've got our A, we've got our B, but we don't know that this is centered at the origin. And honestly, seeing that this major axis, I don't see a 0 in either of these coordinates. That's a really, really strong indicator that that is not centered at the origin. So we need to figure out the H and the K value. Okay. So if they gave me those vertices, this is what I'm going to kind of do to figure this out. If my origin, if my center is not at the origin, I need to look at those vertices that they gave me here. I do see that they both have the same y value. So when I'm looking at the options here, I want you to look and say, which of these situations do we think that's more like for our vertices? Well, on this one, that y value is the same in each one. That's the k value, actually. Whereas on the vertical axis one, that y value changes, k plus or minus a, right? So that I don't want the y value to change. So that means it's going to be like the horizontal axis version, okay? So I should be able to gather that, okay? We're going to look at my vertices being -2, -1, and 8, -1. And what I can gather from that is that k equals -1, okay? We also can gather from that it's a horizontal axis. I'm going to make a note of that in just a moment. But I want to figure out what is my h value. I've got k, but I'm going to need h, and then I should be good to write the equation. So keep in mind that formula again for vertices, that's h plus or minus a for whatever that x coordinate is. So pick one of the x coordinates, and I'm going to go with the larger one, okay? And I'm going to do the option where it's a plus H, or H plus A. Sorry, I should have that order swapped. 1 second. That will match. It does the same thing, I know, but to match exactly what the equations are that I've given you, we would have the H, and I'm going to say the plus A option. That's going to give me 8. If I had done H minus A, that would have been the negative 2. Okay, so make sure that you're keeping that in track. But yeah, so H plus A equals 8. I know that A is 5. So H is going to have to be 3. And then we can give our equation. I'm going to follow the fact that this was a horizontal axis. Okay, we're going to follow that pattern, and I'm just going to fill it in. So for the horizontal axis one, we had x minus h, so that's minus 3 squared. That's what's going to be over a squared. A was 5, 5 squared is 25. Then we have plus y plus 1. If k was negative 1, this is y plus 1 over b squared. B was 4. 4 squared is 16. This is equal to 1. So it's just piecing together all those puzzle pieces to get that equation. Ta-da! All right. Guys, we've got one more example here. Then I think my next one I'm going to put in a third video, just because the next one is going to be a little bit time consuming and a little bit challenging. It uses a lot of the completing the square stuff. So I'm going to let that be, example 6 is going to be its own video. I'm just going to do this one more, and then we will be done with this video. Okay? All right. So we are now at example 5, where it says find the center, vertices, and foci of, and then they gave me an equation. Well, center is pretty easy to get. I can just look H and K. But I also need us to think about the fact that they didn't actually put the equation in the order that we typically like to see. We like to see that the A value is going to be the one that comes first. That helps me to see which way this is actually opening and which set of equations to use. So it's almost like they're trying to trick you by they put X first. But do you see how 9 is a smaller denominator? So that means that that's going with B, whereas the 49 is A squared. So the first thing I'm going to do to kind of help us out on this one is actually rewrite it. I'm going to rewrite this so that we have the order that is going to line up with our stuff a little bit more. That way I can more clearly see A squared is 49, which means A is plus or minus 7. I can see B squared is 9, which means B is plus or minus 3. Just right out the bat. And then I do, to get the foci, I'm going to need to know that C value. So let's find the C value by using that A squared equals B squared plus C squared situation. A squared equals B squared plus C squared. Okay, so that's 49 equals 9 plus C squared. That's 40 equals C squared. Square root of 40 is what we're looking at for C, which I can simplify to be 2 root 10 for that C. Okay, so right there, I've got C. I know that took a little bit of mathing to do, but we got it. All right, so let's identify something. Since we have this order where the y squared is over the larger value, then this is going to be the vertical axis option, and our center being at HK. So I think we have all the things that we need, because I see my H, right here, H, I see K. We've got A, B, and C. I think we've got everything we're going to need. So let's go ahead and start looking for what they've asked us for. They've asked us for the center. So our center is going to be at the HK. So that's going to be at -2. Remember, H is always with X. And then K, +5. All right, vertices. Let's talk about those. Now, for this vertical axis center at HK situation, our vertices are going to be the H and then K plus or minus A. That's what we're looking at for those vertices. So we're looking at H and then K plus or minus A. All right, so if I've got H and K here, this is H is -2, K was 5 plus or minus 7 is what A had been. So I should be able to get my two vertices this way. -2 and then 5 minus 7 is -2. And then our other one is -2, 5 plus 7, which is 12. So we had our center, we've got our vertices. Now time for the foci. All right, foci, still using the same set of equations, but pick the foci one. That's H, K plus or minus C. All right, H, K plus or minus C. H was again -2. K was 5 plus or minus, C. So this is a pretty ugly thing to try to add, okay? I'm okay if it's irrational like this. I'm okay with you leaving it as plus or minus like that and not cleaning it up anymore. Because, honestly, you can't really get it much more clean. The only other thing you could do is maybe list it as -2 and then 5 minus 2 root 10 and have a separate point where you had the -2, 5 plus 2 root 10. And honestly, that's not much better. So I'm just going to let this be. If it's irrational like that, I'm just going to let it say we can write it as plus or minus, and that's okay. If it was actually an integer, go ahead and combine them and simplify that out so that we can see those 2 points clearly. But if it's irrational, I'm okay if you want to leave it like that. Okay, we got our center, we got our vertices, got our foci, done. Like I said, this video is long enough, and I don't think that we're going to fit example 6 into one class period with these, so that's fine. I'm planning on putting that on another day anyway. So in the next video, you're going to see us using completing the square quite often to be able to write the standard form of these ellipses. And so I would definitely make sure that you watch that one if you missed that lesson in class. All right, and I'll see you then. Bye.